Alright, this video is about circles and exterior intersections of secants or tangents. So there's a cool relationship there. So we call these exterior intersections. So that's when these two lines or tangents or secants intersect outside of the circle. So like right there. And how do you find that angle? Well, here's the relationship, which is kind of cool. It says if secants and or tangents intersect on the exterior of a circle, then the measure of an angle formed is equal to half the difference of the intercepted arcs. Half the difference of the intercepted arcs. So in this example here, the intercepted arcs would be arc CE and arc BD. And so the measure of angle A would be equal to 1/2 the measure of arc CE minus the measure of arc BD. Okay, so you take the difference. That means you're subtracting this time. All right, in the second example, we have a tangent and a secant intersecting, again, outside of the circle. And the intercepted arcs in this picture would be, let's change colors, BD and BC. So the measure of angle A in this drawing would be 1/2 the measure of arc BD minus the measure of arc BC. And then the last one, we have two tangents intersecting out here. And the intercepted arc in this picture would be BC, clear to there, which is the major arc. Actually, we would call that BDC, because the other arc here is BC. So we can't use BC both times. So the major arc, we use 3 letters, BDC. So this would be equal to 1/2 the measure of arc BDC minus the measure of arc BC. Okay, so that's the relationship we're going to practice in the next 2 slides. And hopefully you'll get the hang of it. There's some algebra involved. Okay, so here we have an example of the same situation. We have an exterior intersection. So the measure of angle KLM is going to be equal to 1/2 the difference of the intercepted arcs, which would be this one and this one. So that's 140 minus 66. So we'll do the math on that. $74. So half of 74, let me put that intermittent step in. Half of 74 would be 37. Okay, let's look at this other example. So here we have an angle C, which is formed outside of the circle on the exterior with 2 secants. So that means angle C here is going to be half of this arc measure minus this little itty bitty arc measure here. However, they don't give us the itty bitty arc measure, okay? But notice where that goes through, the center. So BA is a diameter. So that means this is a semicircle here we're looking at, right? So this is from here to here. Here to here is 180 degrees. It's half of the circle. and we know that this arc is 67, this arc is 94. So if we subtract those two from 180, we'll get the itty bitty arc BD that we need. Okay, so I'm going to do the math on that and pause the video because these videos get too long when I don't do that. Okay, so the measure of arc BD turns out to be 19. We got that from subtracting these two arcs from 180. Okay, so to find the angle that we're wanting, it is going to be half of difference between 67 and 19. So we're going to subtract 19 from 67 and get 48. And so half of 48 is 24. So the measure of angle C is 24 degrees. I did not write that down because I was running out of room. So let me fix that here. So what we did to find that angle, we did half of 48, which is basically 48 divided by 2, which is 24. Okay, that's how we got that. Okay, now you should pause the video and try this one on your own. These ones are actually a little more challenging. These aren't the basic ones. But see what you can do with them. Okay, so on this one, if you use the relationship given, angle U is going to be half of the difference of the arcs SW and VT. We're trying to find SW, so I just called that X for now. Anyway, when I write that relationship out, it says the measure of angle U is half of the difference of SW minus TV, those arcs. So now I put the information in. That would be 40 degrees is 1/2 what we're trying to find, I call X, minus the arc VT, which is 75. So now to get rid of the 1/2, I'm going to multiply both sides of the equation by 2. That gets 2 times 1/2 is 1. And then the arc we're looking for will be 80 plus 75. And that equals 155. Okay, on this one, this angle will be half of QU minus TR. So 35 degrees is going to be 1/2 the difference of QU, which I'll call X, minus this little arc TR, which is 46. So to tackle this fraction, to get rid of a 1/2, multiply both sides of the equation by 2, because 2 times 1/2 is 1, and that cancels. 35 times 2 is 70. So the measure of that arc will just be whatever 70 plus 46 is. 116 degrees. Okay? All right, new relationship here. Hope it's not too confusing for you. And I hope you're doing well. Bye.